So the next part of this part number is the foil type. In this particular case, it is an A foil. An A foil is constant tan. It's one of the oldest alloys that's used, if not the oldest alloy used for a typical foil strain gauge. It's a nickel copper alloy, has a gauge factor of about 2.0. And one of the things you'll notice in this table is that it can be temperature compensated. We can compensate it for materials anywhere from a 00 all the way up to a 50 part per million per degree Fahrenheit material. A 00 would be titanium silicate or Invar. 50 would be an unfilled plastic like maybe a vinyl or maybe a polycarbonate or some other type of plastic. On a relative scale, you'll notice this fatigue performance is good. It's not the best, but it's a very good all-around alloy for strain gauges and the one that's most widely used. And then maximum strain range, you'll see that it's rated to 6% strain, which would be 60,000 microstrain for a one-time elongation. The one right below that on the table, that's the annealed constant tan. It's the same metal. The difference is that the P foil has been fully annealed, and what that means, it's soft. And the reason it's soft is that we want it to go to a very high strain level. And in this case, we rate it up to 20% strain. So when you combine P foil, for example, with the E backing, you get a combination that can go up to 20%. Now, you gain something and you give up something. You gain the elongation capability. The thing that you give up is that it's not very good in fatigue. So P foil gauge is there for a specific purpose, and that is for very high strain levels. The third one down is a modified Karma. This is basically a nickel chromium alloy. Has a gauge factor about the same as constant tan, maybe slightly higher. We have it shown at 2.1. You'll notice the STC availability is anywhere from 0 up to a 15. So most metals we have pretty well covered with the STC matching of the Karma. Fatigue performance is very good, better than constant tan. And the maximum strain range, it's rated up to 2%. Karma also, you'll find it has better long-term stability. So for customers that are installing strain gauges, maybe inside of a wing on an airplane, and they want it to last for many, many years, I would recommend using a Karma alloy gauge. I think they'll hold up a little bit better long-term than you'd find with a constant tan. When we're talking 15, 20 years of service life, I would recommend using a Karma alloy gauge. And then the last one is Isoelastic. That's the D foil. And it's an iron nickel alloy. One of the great things about it, you'll notice, is that it has a higher sensitivity. The gauge factor is 3.2 as opposed to 2 or 2.1, so it's about 50% more sensitive. You gain something, you give up something. You gain the sensitivity, but you have to give up something, and the thing that you give up is that it cannot be temperature compensated. So when you see the STC availability and we have a DY in place of a number, what that means is that it's only for dynamic testing, not for static testing. You'll find this type of alloy generates somewhere in the neighborhood of 70 to 80 microstrain per degree Fahrenheit change, so it almost makes a better temperature sensor than it does a strain sensor if you're trying to use it for static measurements. But you can't do that. So what we typically suggest is if you're going to use an isoelastic foil strain gauge, you really need to be using a filtering circuit on your data acquisition or on your signal conditioning that'll get rid of the slow-moving changes and only allow the higher speed changes to pass. So typically where we see isoelastic gauges used are in fatigue test studies, things like helicopter blades where you're going to put them on a table and excite them for hundreds of thousands, if not millions of cycles. Then isoelastic foil is the right one to choose. So it has the best fatigue performance. You look at the maximum strain range. Again, you gain something, you give up something. The thing that you give up is that you're looking at a maximum strain range now of 2% as opposed to like 6% with the constant tan.